Alright, so the focus of this lesson is we're going to talk about lines, planes, and angles. Mostly I'm going to talk about planes just so you know what I'm referring to when I say the word plane. So planes are two-dimensional surfaces like a floor or the ceiling or a wall, and they go on and on forever. Parallel planes are planes that never meet, like the floor and the ceiling, hopefully, if the builder was good, and if the floor and the ceiling extended out forever, they would never meet. And here is a little picture of parallel planes. So coplanar, this is another word you're going to hear. Coplanar means they are on the same plane. So if we look at this top plane, we have point F. If I put a point here, okay, and called that X, and I would say F and X are coplanar. The point X and G, however, are not coplanar because they are not on the same plane. Some important kinds of lines we have are lines that never intersect, and by intersect I mean they never cross. And lines that never intersect are either parallel. A parallel line you could think of like a railroad track. Road track. Or skew lines. And skew lines are lines that are not on the same plane. So if I had a line on this blue plane up here, like that, and I had a line on the green plane down here that looked like that, even though they're going kind of in different directions, they're never going to meet because they're not on the same plane. Alright, the parallel postulate. The parallel postulate. Basically, what the parallel postulate tells us is if I have a line, like this one right here, there's a point that is not on the line, and you can see that black dot up above it, and there's a green dot below it now. There's only one line that's parallel to our original line that goes through that point. And let's see here. So if I drew that, pretend that's a straight line. It's hard to draw a straight line with my finger on this thing. So there you go. There's a parallel line through that black point that's parallel to the bottom line. And there's only one line that goes through that point that's parallel to our original line. Other lines of interest that are important are perpendicular lines. And perpendicular lines are lines that cross at a right angle, or 90 degrees. So there we have two, if I call this line L and this line M. L and M are perpendicular to each other. They meet at 90 degrees. And the perpendicular postulate is pretty much like the parallel postulate in the sense that if I have a line and I have one point that's not on the line, that's the point, then there's only one line that goes through that point that's perpendicular to the original line. And there it is. Okay. So perpendicular lines meet at 90 degrees. Parallel lines never intersect. Transversal. So a transversal is a line that intersects two or more coplanar lines. So remember, coplanar means on the same plane. So it intersects two or more coplanar lines at different points. So let's say I have this line here. And that's line, we'll call this line P. And then I have another line here. And we will say that is line R. And so a transversal, and I'll do this for effect, a transversal crosses those two lines at different points. So this red line is our transversal. moving right along. We're concerned with the angles that are formed by transversals. So the first one, corresponding angles. They have corresponding positions. So let me draw a little picture. Here we have our two lines, dupe and dupe. Notice they are not parallel, and they're not perpendicular. Let's go back and change our transversal. This time will be green, just for excitement. So there's our transversal. And then what I'm going to do is I am going to give each of these angles a number. So I've got 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So corresponding angles. Corresponding angles have corresponding positions, meaning they're on the same side of the transversal and they are in the same position with respect to their line. For example, angle 2 and angle 6 are corresponding. So let's do a little line here, and I'll say 2 and 6. 2 and 6 are corresponding. And they're corresponding because they're both on the same side as a transversal, and they are both above their respective lines. So 2 and 6, 4 and 8, 4 and 8 are also corresponding. 1 and 5 are corresponding, and 3 and 7 are corresponding. So there are some corresponding angles for us. Now let me erase this. Whoopsie. Let me hit the right thing. Why is that not erasing? Oh, hold on a sec. Okay, it's apparently not going to erase for me. So we'll just keep those arcs there. Alternate interior angles. Now, alternate interior angles, they lie between the lines. So they lie between like line L and line M. So on the inside of the lines, on the opposite side of the transversal. So some examples of alternate interior angles would be angle 5 and 4. So 5 and 4 are alternate interior because they're both inside their lines, and they're on opposite sides of the transversal. 3 and 6 are also alternate interior. So there we have some alternate interior angles. Alternate exterior angles, again, they lie on opposite sides of the transversal, but this time they lie on the outside of the lines, meaning they would be out here or out here. So some examples of alternate exterior would be 1 and 8. You draw a line there so it separates them. So 1 and 8, and 2 and 7. And then the final one, the consecutive interior angles. So I think a consecutive is sort of like in a row, one right after another. Consecutive interior angles lie inside the two lines, so they're going to be inside these two lines, but they're on the same side of the transversal. So examples here would be, let me draw a little line down here, would be 3 and 5, and 4 and 6. Okay. So there is a brief discussion about lines, planes, transversals, and the angles formed by them. I'll see you in class tomorrow.